Hi, this is Junaid. We're going to go ahead and start discussing each and every large language model starting with GPT-3. Let's find out. So anytime you're actually looking at these new technologies, especially large language models, you should get into the habit to get to the source, where the source actually is. Most of these technologies will either be published with a proper publication paper like BioGPT, etc., which we'll discuss, or they will have a technical report. Now, technical report is released by the company itself. That does not mean that it has been peer reviewed. It does not mean that it has been, vetted, etc. But at the end of the day, we get the right glimpse from the people. Now, understand that this could technically be propaganda because some of these people are actually directly from the company that are representing it. But at the end of the day, going through this method is much better than going through all of the other channels like YouTube and Twitter, etc., to get the sense of what that actually is. Because again, understanding GPT technically represents generative pre-trained transformer models. But when they are used in the large language models like GPT-4, they turn into what I call GPT, which is the most important word of the century, that artificial intelligence is now general purpose technology. So therefore, when you have a general purpose technology, you have to make sure that you understand these things to find the right large language model for the right application. And this is what we are here to do. So let's start with GPT-4. Now GPT-4, they basically developed that there is a large language multi-modal model. So that's very important. So first of all, it is important to understand that it is a multi-modal model. Now we're going to talk about what multi-modal is. Multi-modal means that it does not only do with text, it actually has images, it has voice. So it can actually do multiple things as compared to just text only. Number two, it exhibits human level performance. And that's very important to understand that what human level performance in especially these academic benchmarks and professional benchmarks. And that's where one of the things that is extremely astonishing to people is like how good they do, especially in professional test takers. We're going to talk about USMLE as a completely separate paper because they don't discuss this in this paper. But they did lawyers, they did other academic papers, and they were finding out that they are actually achieving human level, expertise and human level performance for these benchmarks that are consistently being used in academics or other various professionals. The post-training alignment, and this is very important. Now, large language models are, you get the data, you vectorize the whole internet, and then you are actually doing the self-attention, what is the proximity of each word to another. And if you want me to do a video on how transformers work and an explanation on that, leave it in the comments, I'll look into it. But at the end of the day, the post-training alignment is the key variable. How you tweak the large language models, because Llama has done it, right? Facebook has one. Watson is going to come. IBM is going to come with that. Amazon is coming up with I think it's called Triton or something. And then of course Google is coming on with Palm 2. But the changes, the real essence of it is that how they're weighted, how they're biased, and those weights and biases are going to be translated in how you're going to get the output from. So that's why it's very important to understand that how post-training was done, because these are generally trade secrets, so they're not going to share it. But at the end of the day, improved performance and measures of functionality, adherence to desired behavior. And that is where the zero-shot learning and few-shot learning comes in. And if you want another video on prompt engineering, we can do that. Again, keep telling me in the comments what you guys want to know, and then we'll go from there. This is one important thing. One of the biggest things about these large language models, because they're so big, it can be used in so many applications, they need to ensure that they behave predictably across a wide range of scales. And that's the key thing. And that allows us to predict some aspects of GPT-4 performance based on models trained with no more than 1,000th of the compute of GPT-4. And this is actually one of those things that they want to understand, that if you compare with specific domain level models to this huge large language model, and does it beat this one? Because that's important. Because if they can do a general purpose technology, it can be used in anywhere. And that's where the selling point of these large models are. One of the benchmarks that they regularly use is MMLU, which is they have like a 57 subjects, question and answers, and they use it regularly in the academics to actually test these models. One of the things that it is generally better in English, margin in English. However, there are different languages that they can check, French, Germany, etc. Again, left to right languages are better represented on the internet anyways, as compared to Hindi, Arabic, Urdu, etc. So therefore, those are the things that are definitely more represented in the data group, and therefore the performance is better on those groups as well. Now, um, depending on some of the risks we foresee around bias, misinformation, over reliance, privacy, cybersecurity, proliferation, and more, it's, those are the things that we are going to also discuss as far as when we are talking about both capabilities and limitations. And this is literally everything you should know. You should know about how it does bias, disinformation, over reliance, privacy, cybersecurity, proliferation, etc. And those are the things that whenever you're using any new technology, especially in artificial intelligence, remember, this is all statistics. These are all predictions. These are technically, at the end of the day, you are on the card table and you want to know what the next card is. It is literally freaking prediction. Prediction after prediction. It is starting from one word and it's predicting the next word, the word after, and the word after, and therefore it forms a whole sentences, a whole paragraphs, and someday probably whole books. But at the end of the day, it is predicting. Um, one of the things they of course go through is that what is the particular scope and limitation of this particular technical report. Some of these things are fairly technical. Predictable scaling, as I said, one of the key things of all these companies who are making these large language models, they want to make sure that these are actually predictably scaling, and that's the key thing that they're looking for. One of the things when you're looking at designing these large language models is making sure that the loss function is predictable, because if you don't have the loss function tailored in, then you're not able to actually predict it better. Again, these are more technical things, so it's not particularly important for us physicians to understand like how we are going to implement these technologies into fine-tuned large language models, pre-tuned or in context learning, or basically simply prompt engineering at the level of the users. The scaling capabilities of human evaluation. So that's one of the things that I always look at, because one of the things that they trained is through RHLF. So I don't know if you remember, it's RHLF. Reinforcement, sorry, that was wrong. RL, reinforcement learning due to human feedback. And that is actually that what they're looking at. And one of the things that they have done is that having a sense of capabilities before turning into improved decision. So once the human provides feedback, that one of those metrics is human evaluation data set as well. So one of the things that they are actually looking and making sure that scaling of capabilities on human evaluation, this is one of the major data set that they concentrated on, because they wanted to make sure when there's human evaluation data set, which they have and they paid for it, that is one of the strengths of OpenAI and GPT-4, because they paid thousands of human beings to actually rate the responses, and then eventually when the human evaluation came back, that's why the responses are much better as compared to some of these things, of course, which this is just the beginning, right? At the end of the day, Bard AI from Google is coming out, Watson X is going to come out, Amazon Triton is going to be coming out. I mean, these are going to be part and parcel of all the softwares moving forward, because again, we're going to go through all of this in a bit, but you're going to understand this. One of the things they're looking for, code based, because again, one of the things that this is very good at is actually code prediction. So once you are able to write in code, and if you have used, or some of your colleagues have used, again, may not be applicable to physicians, but they use what we call Copilot, and it literally is able to predict the next code itself while you're writing software code. It definitely improves about 50% of efficiency. So advanced coders and seasoned coders who have been using this swear by it, that how good it is. Not to mention, of course, now Amazon is out with Code Whisperer, and then of course Google is never going to be behind about this, and Google is also in Palm 2. They have this special area where they have specifically tried to solve the coding problem itself, because again, every company is trying to making sure that they are performing the best in these capabilities as well. One of those things, like, I'm going to go through this is a very good example, but this is just mind-blowing. So GPT-4, which is multimodal, and GPT-4 with no vision, one of the times they do that is basically decrease the actual the size so that its latency is low, because the first is that is it word or voice or image, so they sometimes remove it. And as you can see, uniform bar exam, which is honestly a little worse than USMLEs as well. And they're going to basically see that there is significant improvement in GPT-4 in terms of this. And this is exactly when you're looking at these things like bar exam, GRE, medical knowledge, self-assessment, etc. These actually tell you that a lot of questions on those are about reasoning. And that's where the GPT-4 is much better than GPT-3, because 3.5, which is mainly, if you don't know what it is basically ChatGPT. So ChatGPT is 3.5 and GPT-4 is the next version over. And you're going to see that one of the biggest advantages of GPT-4 over this is by ChatGPT-3. Now, exam results, right, as you can see in this dark blue is GPT 3.5. As you can see, it has actually been tailored towards GPT 3.5. So what you're looking over here is that this is basically GPT 3.5. So they already did very good on environmental science, brew art, history, psychology. But if you can look, they did bad on calculus. They continue to do bad on calculus. But GPT-4 at least took up to 40%. AMC, coffee grounding, English, AMC, bar exam. As you can see, GPT 3.5 was sucked. And now look at this. It is actually above 90%. And this actually over here, chemistry, quantitative physics, semifinal. And this is going to be changing the way we actually do this, because again, the ability of these models to do reasoning is actually getting better and better. Clearly, when you look at GPT-3, this is 3.5 and GPT-4. Now, one thing you need to always understand is this 5 shot. Again, if you say write an abstract or something, and this is one shot basically, and that's called zero shot theory. To get the right answer, you have to give multiple shots. Basically, you have to give them, okay, what about this? Okay, no, this was not right. Trying to do this, because you're basically having a conversation with these large language models. So whenever you give a prompt, that prompts are there. So these are tested with 5 shots. Some of them are tested with 10 shots. Some of them are tested with 25 shots. So again, if you're not getting an answer right away and you're saying, what the hell, they're publishing 86%. Yes, because they use 5 shots. You have to use 5 shots to get that 86% performance as well. But anyways, you can see from GPT 3.5 to GPT 4, there's a significant improvement in MMLU, which is the multiple choice questions from 57 subjects. Hello swag. To be honest with you, I don't know this. Somebody knows it. Give me that. And of course, these are human eval Python coding tasks. And one of the things that they have realized that if you are training, let's say if I'm training a brand new large language model, it's one thing to do it on Wikipedia and the rest of the internet, but it is essentially important to actually give them code to understand code. Interestingly, when you give them computer code, the overall ability of large language models to start reasoning is much better. So if you're developing a large language model, make sure that you include coding as a data as well. Interestingly, this is very always an important for me, because I look at languages as well. I come from Pakistan, and I want to make sure that some of these languages are acceptable or shown. Interestingly, 3.5 was actually around only 70%, and you can see that GPT-4 is 85.5%. So there's a significant improvement as far as this is concerned, and not bad. I mean, the Urdu is about 73%. They don't show us basically what so around 70% or so. Same thing with Bengali, and you can look at Arabic, etc. And depends on the data and how structured that data is available. So you can see that improvement in language is actually significantly improving as well. Now, of course, one of the key essence of this is multimodal imaging. And they give this example that, hey, show this lightning cable adapter for these 3 panels, and it can look at the actual image and then figure out what kind of, packaging is it there, and etc. And then they go into limitations. Again, it is very important that you get up and read that particularly by yourself. And then one of the things is internal factual evaluation by category. And that is how factual it is, because at the end of the day, it is generating and it's predicting the next word, and sometimes it's going to purely bullshit, and that bullshit is actually called hallucinations. So these hallucinations can happen with these models as well. You can see learning, technology, writing, history, math, science, recommendations, code, and business, and each of every category GPT-4 does much better. However, I'm going to be honest with you, when I use GPT-4, it's a little annoying because it takes a while. The latency is significantly higher because it's a bigger model, and honestly, it is very, very expensive as well. The building things we're building on GPT 3.5 Turbo because the latency is very low, and then we can do the prompt engineering to improve what we need, even with zero-shot learning. So the way that we are approaching this is different, but anyway, they have to serve a huge market, of course. But the idea is that when you have these kind of things, you have to understand that how to get, better results. GPT-4 answers correctly. These are very few examples that you can go through by yourself when you're reviewing this article. And of course, there are risks, adversarial testing by a domain expert poses similar, such as large language model generating harmful advice, buggy code, inaccurate information. These continue to happen, and that is something you should be aware of when you're looking at it. You should not copy paste whatever comes from ChatGPT and just move on. You literally have to check it. This is, again, disallowed prompts are very important. Make me a bomb, and that's going to be say, hey, these are dangerous chemicals. They're not going to answer that. These are some of the things that they have improved in terms of making sure that this does not give you information that is harmful. Model assisted safety pipeline, and again, this was done with human feedback as well. And they're using rule-based reward models as well for zero-shot learning classifiers. So the minute you do these semantic classifications, so the ability for you to get the right answer on the first question, that's called zero shot, is actually improved in GPT-4 as well. How can you create a bomb? As I told you, these are things that they're trying to do. There are significant improvements in the safety metrics. Again, I'm not aware of really large, government-based FDA approved safety. Like we have FDA, right? There's no safety for AI. Maybe they should be. We can talk about this in a certain thing in a future video. But at the end of the day, we're looking at that these models have some more increased safety metrics. However, these metrics have been self-invented, at least that I know of. If I'm wrong, please correct me. So therefore, again, prompt type, sensitive prompts, and disallowed prompts are actually much better in terms of GPT-4 when they're looking at this as far as compared to 3.5, which was the last one. So in conclusion, what they're saying is a large multi-modal. So that's key thing. It can do data. It can do text, audio, voice, and then eventually they're going to continue to. So the multimodal is currently it's image and text, but they're going to continue to evolve on that. GPT-5 is not going to be any more different in my opinion as far as reasoning, but then it's going to add video, it's going to add voice, it's going to add ability to watch graphs, etc. So therefore, this is the multimodal thing that has started. Professional benchmarks reports state-of-the-art systems which often include task-specific fine-tuning. So they have included a lot of fine-tuning within that GPT-4. So if you're a lawyer coming in and you just ask GPT-4, there's a high chance that that particular task-specific fine-tuning is built in within that system. How predictable scaling. And again, this is very important to them. They build system to be used by billions of people like Microsoft and Google. So therefore, that is something that increased capability, difficult some methods taken to improve safety and alignment. And clearly they talk about safety. I'm going to be honest with you. I don't know if it's real or if it's just, something. Of course, this is not over. I've just reviewed actually 14 pages of it. The whole document is about 95 pages. And you can go into all these, of course, references that they have pointed out, but they actually go through example after example that how they scored, how they do the model snapshot details, etc., etc. So it's very important that you go through these models if you're building your own fine-tuned model, if you're trying to think of actually building some of these newer models. In the next video, we're going to talk about Palm 2 technical report, which is made by Google. So I have reviewed this. So we're going to talk about what's the differences. One of the key things that you need to understand that ChatGPT was not a search engine, right? It was not developed by Microsoft, who's a Bing search engine one. Palm 2 is developed by a company, Google, which main purpose was making sure to enhance search and translation. So we're going to see the differences between GPT-4 and Palm 2 that is coming on. And of course, we're going to then talk about Anthropic. And these are some of these, how GPT-4s are going to impact the market, etc. So stay tuned for some important context for understanding this new GPT, again, generative pre-trained transformer models. But of course, for me, the more important word for large language models is GPT, general purpose technology. And that is just amazing. Thank you.